have the Bob Ross of Clojure, Zach Oakes, making games at runtime with ClojureScript. Big warm applause. Thank you.
Thank you. Wow, Bob Ross. I forgot about that. Thank you. Yes, I'm Zach. I was going to make normal slides, and then I realized I made a game library, so I'll make my slides with that. So, in order to transition, I have to move the character. So, if I die, this is going to be really annoying. First, let me briefly mention my old library. Sorry, he jumps pretty damn high. My old library is play-cljs, and I don't actually work on it that much anymore. And there are a couple of reasons for that. Number one is it's one of the earliest Clojure projects I ever made. I'm sure all of you remember your old Clojure code. Yeah, it's not good. Well, mine is codified in a library, and it will be hosted on Maven until the sun consumes the earth. So I can't really pretend like it doesn't exist. I made typical mistakes, overuse of macros, a very overly opinionated state management, and I can't really undo that stuff. So also, it's based on libgdx, which is fine, but I'm starting to get more interested in browser-based games because, at least for small games, it's a lot easier to get people to play your game if they just click on a link. And if they have to download a jar or an exe file, it's more work. And also, frankly, that's a security issue if you don't trust the person who made it. So that's why a lot of game jams these days are almost all dominated by web-based games. So anyway, that's my old library. My new one is... No, I coded that in so he wouldn't fall. I knew that would screw up. So this is my new library, and it's based on P5.js, which is part of the processing foundation. And the reason I chose is because it's a fairly high-level JavaScript library, so it's pretty nice to build on top of. And I hopefully made better design decisions as well. There aren't any macros, and most of it is data-driven, as you'll see. So what is P5.js? Well, I already just explained that, so we can skip this slide. Here's a quick example of P5.js. As you can see, it's very procedural code. I mean, that's the code you use to draw that smiley face. It's fill this, then ellipse, then fill this, then ellipse. So what would this look like if we were going to do it in a more Clojure-esque kind of way? Well, I thought, well, why not take all of this stuff and turn it into data? And the inspiration I had was Hiccup and also reagent. You know how we represent HTML as data in a hierarchical way? I decided, well, why not do the same thing? So this is what it looks like in play-cljs. And yes, it is a little bit more verbose looking, but that's because all the options are in named maps, so which I think is better anyway. So yeah, this is what it looks like. It's just hierarchical Clojure data, and you just shove it into this one function called render, which will do the actual rendering. So this would draw the same smiley face. And there's stuff built in for not just images. It has tile map support, which is what I'm using right now for the level. And a lot of other stuff in there that you can take a look at. And so far, it seems to be paying off really well. I was glad to hear that Lisa had a good experience with play-cljs, because I do think it probably has some legs to the idea that you can represent most of your game as just data. Because if you represent it as data, you get the same benefit that you get with like Hiccup in terms of having full access to the entire Clojure language to do whatever you want. You can map over some data and spit out a bunch of different ellipses or something like that. So it's a pretty good experience. If you want to try it out, that's the GitHub. You can also go on nightcoders.net, which has a that's my Cloud IDE, and it has a built-in template for play-cljs. Right now, it's based mostly around boot because I just like boot. You can use line again as well, though, if you wish. But at least the built-in template is just boot focused right now. So yeah, that's it. Thank you very much.
So we're going to have a magic presentation now, which goes without a computer. This is weird, isn't it? Next on stage, Michael Pershyn, 7 surprises in Clojure. Take it away.
So it actually works without a computer. I'm happy to see you here, and I'm going to tell you about my 7 surprises in Clojure. I am originally a C++ developer. Then I moved to C#, and I did object-oriented programming, patterns, design. Then I did some architecture. Then I moved to Python because it was dynamic and very nice. And then eventually I was interested in big data and functional programming, but Python cannot do functional programming that much. And I moved to Clojure, and I do Clojure like 4 years now. I'm very happy about this, and I want to share some experience. So what I know before I moved to Clojure, I know the functional programming is fun because the feedback is very fast, and it makes people better engineers. I've seen some examples. I'm not talking about me, but it works. So the first surprise was a total paradigm shift. And I did not expect that, but it actually changed completely how I perceive programming, how I think about the problems, and how I solve them. And that's actually possible to happily live without all these imperative things that we have. I listed them here. I'm not going to learn them. Part of this paradigm shift was rediscovering the identity state and mutable state. And I still know people who do not make a difference between the mutable state and the identity. It's a very nice picture. I tried really hard to find it, to visualize this paradigm. The second one was that we can actually do the concurrency and not have problems with these trees that are competing for resources. So we go to the next surprise. It was the painless scaling. I did some multi-threading before. I was not happy about this. And in Clojure, it was like this, working. Yeah, so I stopped using low-level concepts, threads, mutexes, semaphores. I stopped thinking about global interpreter lock in Python. And I started debugging this stuff caused by the non-determinism of these mutable threads and writing unit tests for that and integrational tests and God knows what. So my expectations started to grow. And the third surprise was types, that they're there when you need them. That was the part of the surprise. And this function actually does not compile because it has 5 type hints, and it's not allowed in Clojure. Oh, yeah. So it doesn't do something special, unfortunately. But thanks to REPL, I could actually learn quickly, get feedback, and learn. And another one was a type hint. I wanted to make here a type hint for these hosts. Oh, laser works as well. That's perfect. And it was like this, and that was not very obvious. I still don't actually know why this L is there. Yeah. So the next surprise was patterns inheritance. I used to know them all. I could drive them, and I don't use them now somehow consciously. Next one was the consequences of laziness everywhere. So the Clojure is lazy. It's very cool. The problem is sometimes you don't want that, and sometimes you don't expect that. So I had to learn that lazy sequences have some chunks, and I may want to change this default behavior of 32 items in the chunk. I did that. Next one was the history, because somehow my computer department missed that thing. Yeah, that there's Lisp. It's still there. It's working. It's nice. It's stable. It's very concise. That there are actors. There is communicating sequential processes. And it all works now. I'm very happy to use it. And I'm very happy that you're here and you're using it as well. I mean, some of you. The next one was and the last one was that it actually works very good with the big data, because I work in the big data, and I do some processing with Storm and Casca log, and Storm is written in Clojure, and I write apologies in Clojure, I do Casca log in Clojure, and my previous job was like this before, and Casca log, and cascading is like this. And yeah, you can easily manage 100 of those.
1 minute left.
Well, almost done. So it doesn't fit there. I mean, there are more stuff, and I keep finding new. So I just listed a couple ones, like solid base, JVM, Lisp libraries, rapid prototyping, robust production, same language, not like we prototype in Python, we implement this then in some normal language. Yeah, I experienced that. I mean, I'm not saying people do that, but Python is very good actually as well. So next one was core async, very powerful, macroses, and I decided I have to stop here. I decided it's not now, but before. Yeah, so I want to thank you as a dear community that makes it all possible, and keep rocking.
We have Sanel, Zukan, who runs his own desktop environment, EDE,
Yeah.
still, which is based on Fulltick, which I haven't seen like in 20 years or so. Talking about Monroe. Take it away.
Okay. Thank you very much. Okay. We might have problems with the output, but I'm hoping that you are seeing everything correctly. So it's my environment, so please report bugs. Anyway, I'm going to talk about Monroe. Monroe is Emacs client for Clojure REPL. Before continuing with that, how many of you are using Emacs? Fair number. So, and how many of you knows about Monroe project? Okay, you are in good place. Anyway, so this is quick talk overview because we are short on time. I'll go quickly through it, and if you have any questions, feel free to ask it later. So I'll be talking about actually what is REPL, why we need it, current state of clients for REPL protocol, why yet another implementation, and conclude the talk. Actually, REPL is short for network REPL. In case you don't know what REPL is, it's a small shell. Some languages call it shell, for example, like in Python. You run it, you execute some commands, they are returned to you, and that's about it. However, regarding network REPL, the good thing is that you send basically commands over network. You have some server, either locally or remotely. You send something like println or something like that, server will execute and return to you. Benefits of this is that, for example, you have a very capable server and you can send, time-consuming evaluation out there. It will compute it and return to you. Also, yeah, you can run it locally, but one really interesting feature of REPL is that locally you can connect multiple clients on it. Luckily, we have clients for Eclipse, for Vim, for IntelliJ, etc., and it creates how to say that, poor man's collaboration point for your coding. So you can run it locally, you can run it remotely, so you have, for example, your team members connect to it and collaborate with the code, etc., etc. So what is the current state of REPL clients? We have Cider, probably you're already using it. We had actually something called nrepl.el. That was the first implementation of REPL protocol for Emacs. We also have Fireplace for Vim, counterclockwise for Eclipse, etc., etc. Please be aware that this is not full list. Probably there are a couple of more implementation done in the meantime. So, what are the problems I had with current implementations on Emacs? The first one is I'm using Emacs. That is the obvious first problem. The second thing is that nrepl.el is not maintained anymore. And Cider is trying to be too much for my taste. So what are the Cider problems I found? Cider is really amazing project, I have to say that. And Bozhidar is doing amazing job maintaining it. But these are the problems I had. So doesn't have to be that you are having. So the first thing is that it's complex for my taste. The second thing is that it has too many dependencies and many configuration options and key bindings to learn. I like to, simply run something, start something, and run it without reading hours and hours of documentation, etc., etc. It was buggy for me. The problem with Cider is that I was using it for fairly large Clojure project, and it would often drop nREPL connection towards server, and that is really weird behavior, to figure out what's going on. It works on new Emacs versions. I don't believe this is a problem anymore because everyone is running newer Emacs, and it has uncommon flow. What do I mean by uncommon flow? The thing is that when you evaluate something in Cider, again, I will just say that this probably is not current state. It was state, I was using it. For example, when you evaluate something, you have REPL, but documentation strings would be shown in separate frame or window.
1 minute left.
Okay. It has really there's a really uncommon flow for my taste. So anyway, I ended up fighting with Cider windows, trying to organize things, trying to remember shortcuts instead of doing coding. So I create Monroe. Monroe is actually a small Clojure mode that has zero configuration, zero dependencies. It's really fast and easy to start up. It's really familiar with the rest of built-in Emacs modes. Gives you minimal amounts of shortcuts, and best of all, it's really portable. You can use it for Clojure, but you can use it also for other languages. For example, Phil Hagelberg, the guy behind Slingen, is using it for a Lua game. So the main goal is stable, be stable and stable, and the best of all, it's really simple to use. You have a single buffer where everything is evaluated and shown. This is how to install it. Quickly shortcuts, which is for the future. And that's it.
Thanks a lot. Advertising of Monroe, or the maintainer of Monroe. Here we have the maintainer of Cider. Bozhidar again. After surprises, maybe now talk about the rough edges. Your stage.
So, I actually have a surprise for you. I decided to change the topic of my talk, and I'm going to talk about Cider. So, I heard some troubling comments, and I feel that I have to dispel them, and I'm going to abuse the limit for my lightning talk, because you're going to allow me to do so. So, first of all, one clarification, nREPL never died. It was just renamed to Cider. So it is still very well maintained, I'd say. Okay, so last year I spoke a little bit about the current state of Cider, and now in 7 minutes I'm going to tell you everything that happened afterwards. On the 3rd of March, the Liberation Day of Bulgaria, I released Cider Bulgaria, which requires Clojure 1.7 because somebody has to push progress forward, and we have to support ClojureScript eventually. We require Java 7 because nobody deserves to work with Java 6 or, God forbid, Java 5. We've got functionality to run all loaded or all project tests, which is pretty handy. We have something which we call Enlighten mode, which we stole from you know who. It looks like this. You've got this code, you enable this, and you see all the local intermediate calculations which is pretty amazing. And this is another way to debug without a debugger and without anything complex to do in the meantime. We've got auto-injection of Cider's dependencies because it turns out that it was hard for people to update their configuration manually. Very nice, great success. It is now impossible to accidentally break the dependencies of Cider unless you try very hard. If you try very hard, everything is possible. Then on Clojure West, we announced Cider 0.12, named Seattle. What a coincidence. We've got things like conditional breakpoints now, which are supposedly very handy. We've got step-in while debugging, which is also very handy. We've got improvements to the way test results are displayed. You probably have forgotten how they used to look, but now they look better. Basically, we are displaying more data. We've got something which we call Cider auto test mode. When you enable it, every time you reload a namespace with Control-C, Control-K, your tests for the namespace are going to be executed as well, so you're never going to forget to run your tests. Pretty handy. We've got LDoc improvements. For instance, the namespaces of the vars are displayed as well. We've got some crazy features like mouse support. If you hover over something, you are going to see its docstring. I know that nobody is going to use this, but people are saying us, you have to push the boundaries of complexity. You have to add every possible feature to Cider, and we're going to do it. We totally reorganized the menus in this release because it turned out that the menus were wildly complex in the spirit of Cider. So now we have a few extra menus, which are very handy. And one more thing. I spent countless hours writing a real manual. I'm going to emphasize this a bit. I'm going to show you a screenshot of the manual and the URL of the manual, so you can visit it and bask in the glory of the wisdom written in this manual, because the manual is amazing. Then, the fatal release, supposedly the final one. 0.13 California, developed in California, which makes it extra magical. More LDoc improvements. Now LDoc works for non-functions as well, which is pretty cool. It works in higher order functions. If you go to some function that you're applying to another, to some function that you're applying to a collection, yeah, you're going to see its LDoc. We've got unified evaluation command schema, which basically means that finally the evaluation commands are consistent and start with Control-C, Control-V. We've got something really crazy, like tracking of evaluated expressions. You can't really see this on the screenshots, but now when you evaluate expressions, you're going to see tiny indications in the gutter showing you what was evaluated and what is out of sync between the REPL and the code. This is really crazy, very useful, or very unuseful, depending on your point of view. But it made Cider very much more complex. Yeah. So something more useful. Now there is a C also section in doc buffers. I will ignore you.
Half a minute left.
So when you open the documentation for some function, if it happens to have related functions, you are going to see them. You can click on them with a mouse if you're crazy enough to be using a mouse. So pretty handy. And then the release dedicated to Berlin, Cider 0.14. Turns out that the final fatal release wasn't either fatal or final. We've got now some basic support for Clojure spec. You are going to see the specification of functions in the doc buffers. We've got other useful stuff like the ability to rerun the last test you executed. And I'm going to share with you an important life lesson. Sometimes the pain of upgrading Cider is well worth it. And another one, always stock up on alcohol before attempting to upgrade Cider. And just 30 seconds for the future. What do we have in the next release, 0.15, London? We've got nothing. No, I'm joking. We've got a REPL history browser. We've got fancy conditional expressions. They're very fancy. We've got fuzzy completion with company, which is extremely fancy. Yeah. And to make it even harder for people on older Emacs, we dropped the support for them. This is all from me. Take care, keep rocking, keep drinking, and keep using Cider.
We have Michael Jerger coming up, Managing Director of the MySac GmbH, talking about DdaPallet. Your stage.
Yeah. Glad to be here and try to throw some light on a DevOps topic. That's my favorite topic, as you know. Let's imagine you are going to start to do DevOps. So I want just to ask, what will be your options? So first option I have tried and I can imagine is you can use plain bash. Yeah, it's not cool. It's not modular, and it makes not fun. So next step would be to try out Puppet, for example. And if you want to use more than 10 tools in addition, you can drive the whole cloud thing. But it's not the best solution, I think. So if you are good in Python or good in Ruby, you can give Chef or Ansible a try. That's quite good. But if you like Clojure, you should give DdaPallet a try. So what's DdaPallet? DdaPallet is a Clojure-based DevOps system. It's test-driven. Test-driven is first-class citizen in DdaPallet. It's straight. And straight means if you want to fire up a Linux server, we have a small layer around bash, and the small layer around bash is leveraging bash to the functional world. And if you go to the cloud world, then you have a lot of APIs, and we cover all these APIs and leverage these APIs also to the functional world. Okay. A lot of more. So DdaPallet covers the whole lifecycle, so we just need one tool. It's open source, at least, yeah. And yeah, so maybe what does this highest level overview mean one level below? Let's look at the Pallet. Who knows Pallet already? Some of you. So Pallet is a great DevOps framework created by Hugo Duncan. I think about 5 years ago. We are using this framework and we are composing this framework to a DevOps system. So I think startup time would be much farther. Then the second part in the name is DDA. DDA stands for Domain-Driven Architecture. And who knows already domain-driven design from the object-oriented? Yes, there's someone. From the object-oriented world, we left these principles, these good principles, to the functional world. And I think the core principles are we have a good way found to separate infrastructure from domain, and we are enabling domain languages. So you can build up your own language. So infrastructure in terms of DevOps is we abstract away the cloud APIs, we abstract away bash, lower fields, and we enable language, domain language to express, let's say, architectural conventions, network layers, and application stacks. If you are enlightened now, you can view us on our blog. You can meet us on weekly meetups. We are doing remote meetups, so we like to join with every of you. We pair with every of you. And finally, you can also have a view on GitHub. We have a bunch of repositories, a bunch of modules, and we like to collaborate. Thank you.
Thank you. That concludes this year's ClojureD, you can all start crying now, because it's going to take a year until we meet again. You can also consider humming "We'll meet again" while you're walking out. I don't know if you feel like it. You've been a beautiful audience. Thank you. Maybe the speakers can stand up and give a warm applause to the audience. That would be a neat idea. Speakers, please. Nice. Ingo, any closing words? That's closing words. See you next year.